In this video, we want to get familiar with related rates questions. Suppose 3x to the 2 plus 4y to the 2 is 16, and x and y are functions of t. So x is dependent to t, and t is the time, and y is also dependent to t. If dx over dt is 1/2, find dy over dt when x is 2 and y is 1. So we have this relation between x and y. 3x to the 2 plus 4y to the 2 equals 16. When the value of variable x changes, this causes the value of the variable y also changes, because by this relation x and y are dependent to each other. So change in one variable causes the change in the other variable. Here we know that the change in variable x with respect to time is 1/2. We want to find the change or the rate of change in the variable y. We want to know how fast y changes with respect to time when x is 2 and y is 1. This is a related rate question because we want to find the rate of change of a variable with respect to time. To answer these type of questions, we have to differentiate both sides of the equation. Here the equation is this. We have to differentiate both sides of the equation with respect to t, with respect to time. But before we start differentiating this equation with respect to time, let me remind you how we can take derivative of an expression with respect to t. For example, suppose we want to find derivative of x to the 3. Derivative of x to the 3 with respect to x is only 3x to the 2. Now suppose you want to find derivative of x to the 3 but with respect to t. Then for finding this, you have to use the chain rule, because attention, in the related rates questions we suppose that the variables are function of t. So derivative of x to the 3 with respect to t is then 3x to the 2, like here, but you have to multiply it by dx over dt. So every time you take derivative of a variable with respect to t, you take derivative with the derivative rules, but you have to multiply it by derivative of the variable. Here the variable is x, so you have to multiply it by derivative of the variable over dt. For example, suppose you want to find derivative of y to the 2. You want to find derivative of y to the 2 with respect to t. What is derivative of y to the 2 with respect to t? Its derivative is 2y. Derivative of y to the 2 is 2y. But don't forget, you have to multiply it by dy over dt. Let's say we want to find derivative of cosine z with respect to t. Derivative of cosine is negative sine. But don't forget to multiply it by dz over dt. So take derivative with derivative rules, but don't forget always you have to multiply it by derivative of the variable with respect to t. This is how we differentiate an expression with respect to time, with respect to t. Let's back to our question. We want to differentiate both sides of this relation with respect to t. What is derivative of 3x to the 2? Derivative of 3x to the 2 is 6x, but because we take derivative of both sides of the equation with respect to t, don't forget to multiply it by dx over dt. What is the derivative of 4y to the 2? It's 8y times dy over dt, and the derivative of 16 is 0. It's a constant, and the derivative of any constant is 0. Now we use the given information for finding dy over dt. Dx over dt is 1/2. X is 2 and y is 1. If we use these numbers, then we have 6 times x is 2 times dx over dt is 1/2 plus 8 times y is 1 times dy over dt. If we solve this equation for dy over dt, attention, 2 here with 1/2 cancels, so all of this is only 6. If we move 6 to the other side, then from this equation we have 8 dy over dt is -6. And so dy over dt is -6 over 8, or -3/4. So dy over dt is -3/4. Why the answer here is negative? Let me explain it to you. We have a relation, if you notice here, we have a relation between x and y. 3x to the 2 plus 4y to the 2 is 16, it's constant. When x increases by this rate, when the value of x here increases, it makes sense that the value of y decreases, because, attention, 3x to the 2 plus 4y to the 2 is always 16. So if x increases, the y value decreases, and that's the reason we got a negative value for the rate of change in the value of y. Let me show you another example. If 2x to the 2 plus 5y to the 3 minus z to the 5 is 23, and x, y, and z are functions of t, it's important that x, y, and z are functions of t, so we can differentiate each of these variables with respect to t. Find dz over dt if dx over dt is 0.25, dy over dt is -1/3, and x is 5 and y is 1. Again, we have a related rate question, but how we know that this is a related rate question? If you pay attention, we want to find the rate of change of z with respect to t. This shows that we have to differentiate both sides of the given equation with respect to t. We have this equation between the variables 2x to the 2 plus 5y to the 3 minus z to the 5 is 23. If we differentiate both sides of this equation with respect to t, derivative of 2x to the 2 is 4x. Don't forget to multiply it by dx over dt. Derivative of 5y to the 3 is 15y to the 2 dy over dt. And derivative of z to the 5 is minus 5z to the 4 dz over dt. And derivative of 23 is 0. Now we can use the given values for finding dz over dt. But attention, for finding dz over dt, this is our unknown which we want to find. For finding this value, we need the value of x, we need the value of y, which we have here. We need the value of dx over dt and dy over dt. We also have these values. But also we need to have the value of z. But if you look at the question, the value of variable z is not given. When you have the value of some variables and you don't have the value of a variable, simply you can find the value of that variable. How? Don't forget, you have this relation between x, y, and z. So use these values and substitute these values here, then you can find the value of z. If we plug in 5 for x in that equation and 1 for y, we have this 2 times 5 to the power of 2 plus 5 times y is 1, so 1 to the 3 minus z to the 5 is 23. 5 to the 2 is 25. 25 times 2 is 50. 50 plus 5 is 55. So from here we have 55 minus z to the 5 is 23. If we move the 55 to the other side, 23 minus 55 is negative 32. So then we have negative z to the 5 is negative 32. If we cancel negative from both sides, then we have z to the power of 5 is 32. So what is the value of z? Z is the fifth root of 32. Fifth root of 32 is 2. So from this equation, the value of z is 2. 2 to the 5 is 32. Now we have all the necessary values for finding dz over dt. So we have 4 times x, 4 times x is 0.25. X is 5, basically. X is 5. So 4 times 5 times dx over dt is 0.25 plus 15 times y is 1 to the 2 times dy over dt. Dy over dt is given negative 1/3 minus 5 times the value of z to the 4. Z is 2. So we have 2 to the 4 times dz over dt equals 0. 0.25 times 4 is 1. 1 times 5 is 5. So all of this is 5. 15 times negative 1/3 is negative 5. So this is 5 and this is negative 5. 5 minus 5 is 0. So when we simplify all of this, it's equal to 0. So then we have 0 minus 5 times 2 to the 4. 2 to the power of 4 is 16. 16 times negative 5 is negative 80 times dz over dt equals 0. So we have negative 80 dz over dt is 0. From this, if we divide both sides of the equation by negative 80, then dz over dt is 0. Let me erase here. So from here we have negative 80 dz over dt is 0, and then from that dz over dt is 0 over negative 80, which is 0. So under the given situation in this question, when the change in variable of x is this value and the change in variable y is this value, when x is 5 and y is 1, the change in variable z is 0. So this shows that the z doesn't change at all with respect to time at this situation. Now look at this question. If the sides of a square increases at a rate of 8 centimeter per second, find the rate of increase of the area of the square when the side length is 50 centimeter and when the area of the square is 900 centimeter square. First, let me draw a square here. Sometimes drawing a diagram for your question can be helpful. So we have a square and we know that the sides of a square are increasing at a rate of 8 centimeter per second. So every second that passes, each side length is increasing at a rate of 8 centimeter. We want to know what is the rate of increase in the area of the square. Of course, when the size increases, the area also increases. But we want to know what is the rate of increase of the area. If you remember from the previous questions, for solving related rates questions, first we need to have a relation between variables. But here we have a word problem. We have to make the equation from the given question. We have two things in this question: the sides of the square and the area of the square. We have to find a relation between the area and the side of the square. Let's suppose that the sides of the square are x. All the sides are the same, so each side is x. And we know that the area of a square, I use variable a for showing the area of the square. Area of the square is one side to the power of 2, or x times x, one side times by itself. So area of the square is x to the 2. Now we have a relation between the two variables in this question. The area is related to x by this equation. Now that we have the equation, simply like the previous questions, we have to differentiate both sides of this relation with respect to t. The difficult part of solving related rates questions is finding the equation. This question is a simple question in related rates questions. But for starting and learning related rates question, this can be a good question. Sometimes finding the equation is harder, of course. Now we want to differentiate both sides of this relation with respect to t. Derivative of a, like derivative of x, is 1. So derivative of a is 1. But don't forget, here we use the chain rule. Derivative of a is 1, but you have to multiply it by dA over dt. So derivative of a with respect to t is 1 times dA over dt. What is derivative of x to the 2? 2x dx over dt. We want to find the rate of increase of the area. We want to find dA over dt, the rate of change or the rate of increase in the area with respect to time. So we want to find dA over dt. For finding this, we need to have the value of x and dx over dt. The length of the s square, the side of the s square, is given 50 here. We want to find dA over dt when the length of the side of the s square is 50. So we have x and it is 50. And if you read the question, the rate of increase of the side of the s square is given 8 centimeter per second. The rate of increase, dx over dt, is the rate of increase or the rate of change of the side of the square, and it's given 8. So we have to multiply this by 8. 2 times 50 is 100. 100 times by 8 is 800. So the rate of increase of the area of the square is 800 centimeter squared per second. Attention, for writing the unit of the rate of change, the numerator shows the unit of numerator here. What we have in numerator here? Area. What is the unit for area? Centimeter square or meter square or kilometer square. But here the units are in centimeters, so it's centimeter square over the unit of denominator. The denominator is always t, and so always in denominator we have a unit of time. Here the unit of time is seconds, so we put s in denominator. This is how we choose and we write the unit for our answer. In the second part of the question, we want to find the rate of increase. We want to find the rate of increase of the area of the square when the area of the square is 900 centimeter squared. Again, we start with the relation between area and the length of the side. We start with this. We differentiate both sides with respect to time. dA over dt is 2x dx over dt. For finding the rate of change in the area, we need the value of x and we need the value of dx over dt. The dx over dt is 8 centimeter per second. But what is the value of x? Here in this part, the value of x is not given. We know that we want to find dA over dt when the area of the square. So the area is given here. So we have the value of a, not the value of x. But simply from the value of a, we can find the value of x. We have this relation between area and the side, the length of each side. Area is 900. If we take a square root from both sides, x is 30. So when the area of the square is 900 centimeter squared, the length of each side of the square is 30 centimeter. So we use this value for finding dA over dt here. So this equals to 2 times 30 times dx over dt, which was 8 centimeter per second. 2 times 30 is 60. 60 times 8 is 480. And what is the unit of this again? Centimeter squared per second. I hope by watching this video you have learned the basics of related rates questions. If you want to get more familiar with related rates questions and you want to see more difficult questions, watch the next videos that are related to this topic. Thank you for watching.